Hello friends, welcome to my channel. In this video, I will be discussing the subject strength of materials from Kurbian Gupta book, question number 101 to question number 150. So let's start. Question number 101. The maximum shear stress is option A equal to, option B 1/4, option C 1/2, option D twice the algebraic difference of maximum and minimum normal stress. So friends, look at this graph. This is Mohr circle. In this axis, shear stress is represented. This is positive shear stress, this is negative shear stress, and in this x-axis normal stress is represented. This is negative normal stress, this is positive normal stress. So this is the center point of this circle. From this point to this point, this is sigma n maximum. This distance is sigma n max, and from this point to this point the distance is sigma n minimum. So the maximum shear stress we know is the radius of the circle. Tau max equal to sigma n maximum minus sigma n minimum divided by 2. So for this question 101, option number C is the correct answer. Next question 102. The figure 2.40 shows the Mohr circle of stresses for two unequal and like principal stresses sigma x and sigma y acting at a body across two mutually perpendicular planes. The normal stress on an oblique section making an angle theta with the minor principal plane is given by. Friends, I have drawn this figure. This distance is sigma x and this distance is sigma y, and this triangle is OPQ. So the question is asked, the normal stress on an oblique section making an angle theta with the major principal plane is given by. So in this OPQ triangle, the normal stress will be the horizontal length of this triangle OPQ. OQ is the normal stress. OQ will be the normal stress. OPQ vertical length will be shear stress, and this hypotenuse of this triangle OP will be the resultant stress. So friends, for this question 102, option number C is the correct answer, OQ. Next question 103. In figure 2.40, the tangential stress is given by. I told you the tangential stress or shear stress is the vertical length of this triangle. So PQ will be the shear stress or tangential stress. Option number D is the correct answer for this question 103. Next question 104. The resultant stress is given by. In that figure, the resultant stress is given by this hypotenuse of this triangle OPQ. So OP is the resultant stress. So for this question 104, option B is the right answer. Next question 105. The radius of Mohr circle in the figure 2.40 is equal to. So friends, in this figure, the radius of the Mohr circle will be BC. BC equal to sigma x minus sigma y divided by 2, which is equal to the radius of this Mohr circle. So for question number 105, the option number D will be the correct answer, half the difference of two principal stresses. Next question 106. The maximum shear stress in figure 2.40 is equal to radius, diameter, circumference or area of the Mohr circle. We know maximum shear stress in that figure, will be equal to radius of the Mohr circle. So for question 106, the option number A will be right answer. Next question 107. Mohr circle is used to determine the stresses on an oblique section of a body subjected to. Option A, direct tensile stress in one plane accompanied by a shear stress. Correct. Option B, direct tensile stress in two mutually perpendicular directions. Correct. Option C, direct tensile stress in two mutually perpendicular directions accompanied by a simple shear stress. Correct. Option D, all of the above. So option D will be the correct answer for this question 107, because Mohr circle is used for all these three conditions. Next question 108. When a body is subjected to direct tensile stress sigma x and sigma y in two mutually perpendicular directions accompanied by a simple shear stress tau xy, then in Mohr circle method the circle radius is taken as. Suppose this is a body subjected to direct tensile stress sigma x and sigma y in two mutually perpendicular direction and accompanied by a simple shear tau xy. So if we represent this stress system in terms of Mohr circle, then we will get in this axis shear stress is represented, and in this axis normal stress is taken. This distance is sigma x and this vertical distance is tau xy. So this from this point to this point the length will be sigma x minus sigma y by 2, and from here to this point the distance will be sigma x plus sigma y by 2. So the radius will be this hypotenuse of this triangle. Hypotenuse is the radius of the circle. So this square plus this square will be the radius of this circle. So radius will be equal to r equal to root over of sigma x minus sigma y by 2 whole square plus tau square xy, which will also be equal to half into root over of sigma x minus sigma y whole square plus 4 into tau square xy. So for question number 108, option number C is the correct answer. Next question 109. In Mohr circle, the center of circle from y axis is taken as. In this axis shear stress is taken, and in this axis normal stress sigma is taken. So the question is asked here, the center of circle from y axis. That means from this point to this point, the distance OC will be equal to how much? So from this diameter endpoint to this point sigma x, and from this point to this point the distance is sigma y, and C is the center of circle. So the radius will be equal to sigma x minus sigma y divided by 2. So the distance OC will be sigma y plus sigma x minus sigma y by 2, which will also be equal to sigma x plus sigma y by 2. For question number 109, option number B is the correct answer, sigma x plus sigma y by 2. Next question 110. The extremities of any diameter on Mohr circle represent. Option B is the correct answer, normal stresses on planes at 45 degree. Next question 111. The maximum shear stress equal to the radius of the Mohr circle. Option A is the correct answer. Next question 112. The energy stored in a body when strained within elastic limit is known as. Option C is the correct answer, strain energy. Next question 113. The total strain energy stored in a body is termed as. Option A is the correct answer, resilience. Next question 114. The proof resilience is the maximum strain energy which can be stored in a body is known as the proof resilience is the maximum strain energy which can be stored in a body. Yes, option A is the correct answer. Next question 115. The proof resilience per unit volume of a material is known as modulus of resilience. Option A is correct answer. Next question 116. Strain energy is the. Option A is the correct answer, energy stored in a body when strained within elastic limits. Next question 117. The strain energy stored in a body when suddenly loaded is. Option A equal to, option B 1/2, option C twice, option D 4 times. The body subjected to gradually applied load. This is the graph of a body subjected to suddenly applied load. So the stress for this body will be P by A, and stress of this body will be 2 into P by A, because the load is twice as compared to the load for the body subjected to gradually applied load. So strain energy we know U equal to sigma square V divided by 2 into E. V is the volume of the material of the body, E is the Young modulus of the material of the body, and sigma is the stress. So U gradual will be sigma square V by 2E, and U sudden will be 2 sigma square V by 2E. So if we make the ratio U gradual by U sudden, which will be equal to 4. For question number 117, the strain energy stored in a body when suddenly loaded is option D 4 times the strain energy stored in a body when the same load is applied gradually. Next question 118, resilience is the option A energy stored in a body when strained within elastic limits. Option B energy stored in a body when strained up to the breaking of the specimen. Option C maximum strain energy which can be stored in a body. Option D none of the above. So we know resilience is the total strain energy stored in a body. So none of this option is correct. So option number D is the correct. Next question 119. The total strain energy stored in a body is called proved resilience. No. The maximum strain energy stored in a body is called proved resilience. So the answer will be option B, disagree. Next question 120. Modulus of resilience is the proved resilience per unit volume of a material. Option A is the right answer, correct. Next question 121. The strain energy stored in a body when the load is gradually applied is option number D is the correct answer, sigma square V by 2 into E. And the notations are sigma is the stress in the material of the body, V is the volume of the body, and E is the Young modulus of the material. Next question 122. The stress induced in a body when suddenly loaded is option A equal to, option B 1/2, option C twice, option D 4 times the stress induced when the same load is applied gradually. We know the load will be twice for the body subjected to suddenly applied load as compared to the body subjected to gradually applied load. So the stress will automatically be twice for the body subjected to suddenly applied load as compared to the body subjected to gradually applied load. So option C is the correct answer for this question. Next question 123. The strain energy stored in a spring when subjected to maximum load without suffering permanent distortion is known as, option B is the correct answer, proved resilience. Next question 124. The capacity of a strained body for doing work on the removal of straining force is called, option B is the correct answer, resilience. Next question 125. Which of the following statement is correct? Option A. The energy stored in a body when strained within elastic limit is known as strain energy. Correct. Option B. The maximum strain energy which can be stored in a body is termed as proved resilience. Correct. Option C. The proved resilience per unit volume of a material is known as modulus of resilience. Correct. Option D, all of the above. So for this question 125, option number D is the correct answer. Next question 126. The strain energy stored in a body due to shear stress is, option number C is the correct answer, tau square into V divided by 2C. And the notations are given, tau equal to shear stress, C is the shear modulus, and V is the volume of the body. Next question 127. A beam which is fixed at one end and free at the other is called, option D is the correct answer, cantilever beam. Let me show you. This is the beam fixed at one end and free at the other. This is called cantilever beam. Next question 128. A beam supported at its both end is not simply supported beam. No, a beam supported at its both end is called simply supported beam. So for this question 128, option B is the correct answer. Next question 129. A beam extending beyond the support is called, option C is the correct answer, overhanging beam. This is the beam A and B. This is the two support, and this is the overhanging portion. So this is the overhanging beam. This overhanging portion may be on both side or one side. Next question 130. A beam encasted at both the end is called, option B is the correct answer, fixed beam. Friends, look at this beam fixed at both end. This beam is called fixed beam, supported at its both end by the fixed support. Next question 131. A beam supported on more than two support is called, option D is the correct answer, continuous beam. Look at this beam A, B. The beam is supported by the three support A, B, and suppose this is C. So this is the continuous beam. The beam having more than two support is called continuous beam. Next question 132. A cantilever beam is one which is, option B is the correct answer, fixed at one end and other end is free. Next question 133. A simply supported beam is one which is supported on more than two supports. No, a simply supported beam is the one which is supported by the two supports. So option B is the correct answer for this question. Next question 134. An overhanging beam must overhang on both sides. No, an overhanging beam may overhang on one side or both sides. So option A cannot be right. So option B is the correct answer. Next question 135. A fixed beam is the one which is fixed at its both ends. So option B is the correct answer. Next question 136. A continuous beam is one which is, option C is the correct answer, supported on more than two supports. Next question 137. A concentrated load is one which, option A is the correct answer, acts at a point on a beam. It is also called point load because it acts on a point. Next question 138. A load which acts at a point on a beam is not called uniformly distributed load. Yes, the load which acts at a point is called concentrated load or point load. So this is not uniformly distributed load. Option A is the correct answer, agree. Next question 139. A uniformly distributed load may be assumed to behave like a point load at the center of gravity of the load for all sorts of calculation. Option A is the correct answer, right. Next question 140. A load which is spread over a beam in such a manner that it varies uniformly over the whole length of a beam is called uniformly varying load. Let me show you which is the uniformly varying load. Look at this beam, but beam is not the concern. Look at the load. This load is the uniformly distributed load. And look at this load, maximum at this end A and 0 at this end B. This is called uniformly varying load. Next question 141. The shear force at a point on a beam is the algebraic sum or difference of all the forces on either side of the point. Option A is the correct answer. The shear force at a point on a beam is the algebraic sum of all the forces on either side of the point. Next question 142. The bending moment at a point on a beam is the algebraic, option A is the correct answer, sum of all the moments on either side of the point. Next question 143. The bending moment on a section is maximum where shear force changes sign. Option C is the correct answer. Next question 144. The shear force at a point on a beam changes sign from positive value to negative value or vice versa. The bending moment at that point will be 0. No, the bending moment will be maximum at the point where shear force changes sign. So option number B is the correct answer, false. Next question 145. When a load on the free end of a cantilever beam is increased, the failure will occur. Option B is the correct answer, at the fixed end, because at the fixed end the bending moment will be maximum. Next question 146. The bending moment at the free end of a cantilever beam is, option A is the correct answer, 0, because bending moment is maximum at fixed end and 0 at the free end. Next question 147. A cantilever beam of length L and carrying a point load W at the free end as shown in the figure 2.41. So which of the following option is correct? This is the cantilever beam fixed at one end and free at the other end, and the point load is at the free end. So the shear force diagram will be linear. This is the baseline and this is the load point, and this is linear because the load is uniform over the entire span. Next diagram is the bending moment diagram. So we know bending moment is the product of force into distance. So at this point the distance is L. So at this point the bending moment will be W into L, and at this point the bending moment is 0 because there is no distance. So here bending moment is 0 and here bending moment is maximum WL. So if we connect this, we will get inclined straight line. bending moment is inclined straight line over the baseline from 0 to maximum, and shear force diagram is the uniform over the entire span. So out of these 4 options, let's see which one is correct. Option A, capital A is the bending moment diagram and C is the shear force diagram. C, capital A is the bending moment diagram. No. So this option cannot be right. Next option B, capital A is the shear force diagram and C is the bending moment diagram. Capital A, capital A. So this is uniform shear force diagram. So this is right. A is the capital A is the shear force diagram and C is the bending moment diagram. Look at C. Yes, this is the bending moment diagram because here bending moment is 0 and here bending moment is W into L over the base line. So option number B is the correct answer for this question. Next question 148. When a cantilever beam is loaded with concentrated loads, the bending moment diagram will be, this is a cantilever beam, A, B, fixed at one end, other end free, and point load W at the free end. So bending moment diagram we know, inclined straight line, 0 at this end and maximum WL at this end, and length of this beam is L, small n. So bending moment diagram will be inclined straight line over the baseline. So for question number 148, option C is the correct answer, inclined straight line. Next question 149. The bending moment diagram for a cantilever beam loaded with uniformly distributed load will be a parabolic curve. Option A is the right answer, correct. This is the cantilever beam subjected to uniformly distributed load W per unit length. The bending moment diagram will be parabolic curve. 0 at this end, bending moment 0 at this end, free at this free end, and maximum W L square by 2 at this fixed end. How W L square by 2 comes? C. We know bending moment is the product of force into distance. So this is the UDL load, W per unit length. So we know length of this beam is L. So total load will be W into L. And we know the uniformly distributed load UDL acts at the center point of the load. So the load will act at this point L by 2. So to get bending moment, we have to multiply this force W into L with the length L by 2. So we will get the moment WL square by 2 at this fixed end WL square by 2. And the bending moment diagram will be parabolic. Next question 150. The maximum bending moment of a cantilever beam as shown in the figure 2.41 lies at, look at the 2.41 diagram, cantilever beam point load at the free end. So maximum bending moment will be at the fixed end. C is the diagram, C is the bending moment diagram, which is the WL, maximum bending moment at the fixed end WL. So for question number 150, the maximum bending moment will be at the fixed end. Option B is the correct answer. So friends, thank you. I will be back in the next video. Please stay tuned and subscribe my channel for the upcoming more videos. And if you have any doubts about the solution, please let me know in the comment section. Please like, comment and keep supporting me. Thank you.